Oh, I gave you guys an example of the box method too, didn't I? Okay.
Attention teachers, this is last call for flu mist. Please check your list. For all students that have the flu mist, this is the last call in the auditorium. Thank you.
All right, if you guys remember, basically what I just did the first one, I found the GCF and I basically divided it out. But basically when we're factoring, what we're basically doing is looking for the side lengths of a rectangle. Remember when we were multiplying, when you multiply two binomials or two polynomials, the product gives you the area. So in this case, when we're given the area, now we're looking into what two polynomials are going to multiply to give us this area. So what we can do is for how many terms, that's how many basically boxes we're going to create. So we have x cubed minus 4x squared plus 2x. And basically what I'm going to do is look for what height can I use here that I can multiply by each of these boxes times a width to get me each of these boxes, I probably should say. So we want to look for what is a common kind of height that we can use for this side. X. They don't have any numbers in common, right, except for 1. But 1's always going to be a common number. But 4 and 2 have 2 in common, but this x cubed doesn't have anything. So we can't multiply it by like a 2x because then we'd have to use fractions. And we don't want to go through fractions. So x times what gives you x cubed? X squared. X times what gives you negative 4x squared? Negative 4x. X times what gives you positive 2? 2x is positive 2. Therefore, we can write this as x squared minus x times x squared minus 4x plus 2. Again, you can always check your answers, Brian, by applying the distributive property. Does that make sense? Do you have yours written down? Do you have yours? OK. Go through it. Anybody have any last questions on the focus lesson?